Now this type of factoring that we're doing today, I will say is almost as easy as what we did yesterday, almost. And if you remember the type of factor that we did yesterday, that homework assignment should not have taken you very long. It should have been super, super quick and easy. Because remember, factoring is the opposite of multiplying. So the easier it is to multiply, the easier it is to factor. Now, whenever we talked about the multiplying, the first section we did just the distributive property. We just multiplied just one thing into multiple things. And then we talked about the FOIL in the box method. And then the next day we talked about specific special cases. Okay, so like the one from yesterday, where we have x plus 4 times x minus 4, or 5x plus 2, 5x minus 2. That's what we did yesterday. If you FOIL that out, you're just going to get the f and the l. The middle term's going to cancel out every single time. So when you're FOILing it, you only have to worry about the f and the l. There was another special case when we did that section when we were multiplying. And it was these special cases where you're taking the square of a binomial. So, just like we've been doing with all of this type of factoring, a lot of times if we look how it is multiplied, we can go back the opposite direction and figure out pretty easily how it is factored. So the first thing, you have to remember that I mentioned this over multiplying. X plus 5 quantity squared is not x squared plus 25. Absolutely not. It is not. X plus 5 quantity squared is x plus 5 times x plus 5. That's not going to give you x squared plus 25. Okay? This you would have to FOIL out. Now when we did these, I told you guys, I don't want you to FOIL them out. This was like the one day that I was like, I don't want you to show your work. Remember me saying that? And you guys were like, what do you mean you don't want to show your work? Yeah, okay, these are the ones I said no. Follow the pattern. So to remind ourselves of the pattern, let's go ahead and we'll actually FOIL it out, even though I told you not to. So the f is x times x, which is x squared. The o is x times 5, which is 5x. The I is 5 times x, which is 5x. And the L, 5 times 5, is 25. Now, problems yesterday, and actually really all of the problems we've done so far. You have your F, x squared. You have your L, 25. Talked about yesterday. Usually, the O and I combine together, which they can. Yesterday, they canceled out. Today, they don't cancel out. Today, they're the same thing. And if you remember, when we multiply these, it's always going to be the same thing. The O and I are always going to be 5x and 5x, or 10x and 10x, or 20x and 20, whatever it is. The O and I are always going to be the same thing. So once you find the O, the I is going to be the same thing. So that middle term is going to be 10x. So what we're doing today, I want to take you through the factor flow chart. Because guys, I promise you, if you know how to use it, this factor flow chart could be really useful to you if you know how to use it. Okay? So whenever we go through this factor flow chart, we still want to check for a greatest common factor. Probably not going to happen. It did happen yesterday. But if there's not, we're going to count the terms. Now, yesterday there were 2 terms, because remember you said the F and the L, the O and I canceled out. But today, we're going to have 3 terms. Because notice we have x squared, the O and I, and the L. So we're back to this idea of 3 terms. Okay? If you have 3 terms, yesterday I said, okay, we're going to skip that. We're not going to skip that today. This is what we're doing today. Okay? We're going to check if we can factor it, how we're going to factor it today, because it's super quick and easy. It's so much quicker and easier than doing either one of these. The problem is not every polynomial can be factored this way, but it takes a second to check, an extra second to check, and if you can't factor it this way, you definitely want to. So here's how you're going to know if you can factor it this way. So there's 2 things you have to check, and I'll say them, but they probably won't make sense until we actually get into some tables. So as soon as you see there's 3 terms, you want to check if it was a quantity squared. if it is a quantity squared, there should be a square in front and a square in back. Now, not like the shape of a square, like something squared, like an x squared. And a square in back would be like a 9, which is 3 squared, or 16, or 25, or 49, or 100, right? Okay, so you're checking for a square in front, square in back. And then what you're going to do, it says, does the middle term equal 2 times a times b? I'll explain that more in a little bit. But if you can say yes to all of those, we can go ahead and factor it as a quantity square. Okay? So let's jump down here, and I'll show you what I mean by all of this. So if I wanted to factor x squared plus 6x plus 9, and we go through this factor flow chart, we still check for a greatest common factor first, but x squared, 6x, and 9, they don't have anything in common. Okay? Next, we count the terms. As soon as you see there's 3 terms, what you're going to check is you're going to check if there's a square in front. Okay, so what you're going to check as soon as you see that there's 3 terms, we want to see, what we're checking is we're seeing, could I multiply out a quantity squared to give me that? So we have to think about this pattern of, how do I multiply out a quantity squared? Well, the shortcut for these, to get the f, I would have taken this, whatever it is, multiplied it by itself. So whenever it's saying, is there a square in front, it's just asking, can you fill in that blank? Is there something times itself that gives you x squared? X, right? X times x. Okay, so that's the square in front. If you can fill in that gap, you can say, yes, there's a square in front. But then you have to do the same thing in the back, because remember, if you multiply this out to get the L, I would have taken that number times itself. So you're thinking, what times itself would give you 9? 3 times 3, right? So whenever you FOILed these out, you said, okay, x times x, 3 times 3. When your factor flowchart is saying it's a square in front, square in back, this is what it's asking. Can you fill in those parentheses? Okay, now, in your factor flowchart, there's also this right here that says, is the middle term equal 2 times a times b? Okay? It's not enough that you have a square in front, square in back, because the FOILing is the 4-part thing, the F, the L, but you also have the O and the I. So you have to check another thing. You have to check, if I were to multiply this out, yes, I get the F, yes, I get the L, but I also have to check the O and the I. If I were to multiply this out and take x plus 3 times x plus 3, the O would be x times 3, which is 3x. And remember the I? Same thing. Always going to be the same thing. So what we're going to do is we're going to take x times 3. We have to do it twice. Because the O and the I are both 3x. What you're checking is if it matches the middle term. 3x times 2, that gives me 6x. So if you can say yes to all of those, you're going to take that sign and drop it into your answer. Now, how you actually do this factoring is super easy. But understanding this type of factoring just takes a little bit of thinking, okay? So let's look at this one over here. 4x squared minus 20x plus 25. First thing, we want to check for greatest common factor. 4 and 20 have a 4 in common. 20 and 25 have 5 in common. But all of them don't have anything in common. So no greatest common factor. So as soon as I see that there's 3 terms, what we want to do is we want to check, is there a square in front? Is there something times itself that gives me 4x squared? I think yes. Okay, same thing with 25. Is there something square that gave you 25? If you're thinking yes, even if you're not like 100% positive, keep in mind that this is where we're trying to get to. I'm trying to figure out, could I FOIL something out? Could I multiply something out to give me that? Well, to get the F, I would have done that. I would have taken something times itself to give me 4x squared. What times itself gives me 4x squared? 2x times 2x. There's your square in front. Then you do the same thing in the back. What times itself gives me 25? 5. Okay, so what we're doing here is we're doing the opposite of multiplying. So whatever we're doing is we're kind of checking if I do multiply it back out, does it work? Well, if I multiply this out, the f works, 2x times 2x. The L works, 5 times 5. But we have to check the middle term as well. So if you were to multiply this out, the outer terms would have been 2x times 5. 2x times 5, which is 10x. But that's just the O. We also have to do the I. But we already know it's going to be the same thing. There are two of them. The O and the I. So disregarding the sign, 10x times 2, it works. So you're going to take that sign, drop it into your answer. Like I said, this type of factoring really is just as easy as what we did yesterday, but understanding it takes a little bit more to get through, okay? All right, let's get this glued into your notebook. This should be page 29. This is still section 8.7, and it is factoring. We're going to call it PSTs, perfect square triangle unions. Pretty simple, okay? But I want you to understand why they factor this way. Because the thing is, whenever it comes down to it, this type of factoring and what we did yesterday are so similar. And you have to understand when to do what we did yesterday and when we're doing what we do today. So the more you understand the multiplying part of it, the more you're going to understand the factoring part of it. So we'll take the first couple pretty slow, and then I'll kind of speed up, and you guys will see just how easy these ones are, just like yesterday. So number 1, h squared plus 12h plus 36. Okay, so what we're going to do, we're going to start getting in a good habit of going through the factor flowchart for every single problem. So the first thing we're going to check for, we're always going to check for greatest common factor. Remember, this has to be something that all 3 terms have in common. Since that first term is an h squared, they don't have anything in common, so we're going to say no. Then when you count the terms, the first thing you're going to check for, because I have 3 terms, h squared, 12h, 36, right? As soon as you have 3 terms, what you're going to check is you're going to look and see, is there a square in front, h squared, I can actually see that square, and a square in back. So something times itself that can give you 36. Okay. If you can say yes to that, what you're thinking, what you're trying to check, you're trying to see is maybe it was a quantity square. So you're trying to figure out, is there something that I could multiply out to give me that back? Well, as you get the f, what times itself gives me h squared. H. To get the L, what times itself gives me 36? 6. Okay, now remember, 4 parts of the FOIL method. If I FOIL this out, the F works, H times H. The L works, 6 times 6. But you have to check the O and the L. Now, this is easy to do. The outer terms multiplied together are just H times 6, which is 6H. The I is the exact same thing. So if the O is 6H, just remember, this is like H plus 6 times H plus 6. The O is 6H, the I is 6H. So the same thing. They're always going to be the same thing. So you have 6H and 6H. That's the same thing as 6H times 2, just to give you a close way of writing it. So what you're checking is the match. It does. So you're going to take that sign, drop it into your answer. That's all we're doing today. Yes, Paul?
Always going to be that sign you drop in.
It's always going to be that middle sign that you drop down. Good question. Because, I mean, if I change this to an h minus 6 and an h minus 6, that would be a negative 6h. A negative 6h would make that a negative 12h. Yeah, so that sign will always match. Good question. Okay, number 2, let's do v squared minus 14v plus 49. Okay, we're going to talk through this factor flowchart because it is really super useful. The first thing you always want to check for is the greatest common factor. That's just a v squared. You're not going to have anything in common. Then as soon as we see that there's 3 terms, we're going to see there's a square in front. I can see that square. And the square in back. even if we give it like a solid maybe, then we might say, okay, well maybe it's a quantity square. If I were to multiply this out to get the f, I would have taken this times itself. What times itself gives me b squared? B. B times b would give me b squared. To get the L, what times itself gives me 49? 7, right? We're just doing the opposite of multiplying here. Okay? Now, if I were multiplying this out, to get that middle term, whenever we multiply this way, you multiply those together. B times 7 is 7b, but I have to multiply by 2. Remember, you have the O and the I. Okay? Now, disregarding the sign, does it match? It does. When the sign comes into play, that's what drops into your answer. So your answer is b minus 7 quantity squared.
So that's
This is your answer. Okay. Number 3, we do a squared minus 16a plus 64. Okay, we should start with the greatest common factor. That's just an a squared. There's not going to be anything in common. Okay, if I count the terms, as soon as you see you have 3 terms, you should check by the square in front, count the a squared, square back. Even if you give it like a solid maybe, you're like, I mean, it looks kind of fishy. Go ahead and try. See if there's something squared. What squared gives me a squared? What squared gives me 64? 8. You have to check the middle term. So do 8 times a is 8a. We have to multiply that by 2. Why do we multiply by 2? Because it's the O and the I, right? We have the F, the L, and the O and the I are both 8a. Does it match? Yes. So we take that sign and drop it down. That's your answer. Okay, number 4. 4x squared plus 12x plus 9. All right, so we gotta take an extra second here. If I look for greatest common factor, remember it has to be for all 3 terms. This 4 and 12 have a 4 in common. 12 and 9 have a 3 in common. But all 3 of them don't have anything in common. So no greatest common factor. So as soon as I see that there's 3 terms, you have a square in front. 4 squared. About 9. Okay. What squared gives me 4x squared? 2x. What squared gives me 9? 3. Okay, remember, the reason why we're doing this, if you multiply this out, when we multiply this special case, the first terms was 2x times 2x. The last terms were 3 times 3. And then you have to check the middle terms, which would be 2x times 3, which is 6x, times 2 for the O and the I. Does it match? What sign goes in here? Or plus. Okay, see how easy this is? Like I said, it's easy, but understanding it, right, it's still probably kind of starting to sink in, hopefully a little bit. Okay. Key number 5. Let's do 36x squared plus 60x plus 25. Alright, so definitely probably need to take an extra second here. This is our greatest common factor. 36, 60, and 25. So, okay, I have 3 terms. Square in front. So, square back. Okay, so let's see if we can factor it. What times itself gives me 36x squared? 6x. What times itself gives me 25? 5. You have to check the middle term. 6x times 5 is 30x, but it doesn't match. Because you got to multiply by 2, right? Because you have the O and the I. Now it matches. So take that plus sign and drop it down. Okay, let's do one more together, and then I'll have you try 2 on your own. Yes?
So when you get the plus or minus sign, right from the number.
Correct. Correct. Yep. Okay, number 6. Let's do 9g squared minus 24g plus 16. Alright, so we check for greatest common factor. Don't have anything in common. When I count the terms, I have 3 terms. If you have 3 terms, you want to see if there's a square in front and a square in back. So let's try to factor it as a quantity squared. What squared gives me 9g squared? 3g times 3g. What squared gives me 16? 4 times 4. 3g times 4 gives me 12g. Times 2 gives me 24g. This is going to be a plus or a minus. Okay, I want you guys to try the last 2 on your own. Okay, number 7. M squared minus 22m plus 121. And number 8, 25y squared plus 10y plus 1. So for number 7, there is no greatest common factor. I have 3 terms. There is a square in front, square back. The middle term does work out. What goes in my parentheses? M minus 11. Good. Good. So remember, the whole thing is your answer. The parentheses, the square, everything is your answer. Okay? And then here, same thing. There is no greatest common factor. There is a square in front, square back. The middle term does work. So what's my first term? 5. Y. What else? Plus 1. Very good. Very good.